Today's lesson, we're going to talk about double angle and half angle formula. Similar to some and different formula that we looked at it for the last time. So basically your formula will be given and you're going to use one of those formulas, right? So you have all these different formulas. So let's look at example 1. It's a sine theta is 5/13 and it's on the second quadrant. Find the exact value of each of the following. So looking at this double angle, right? You need to know sine, cosine, and tangent. Even though sine is given, you need to know all sine and cosine and tangents. So that's the first thing you need to do. So let's look at the angle. For theta, your sine is 5/13. So 5 here, 13 there. Oh, I say 5, right? And so if we wanted to find the b, 13 square minus 5 square, that's 169 minus 25, 144, which is going to be 12. So if we know all three sides, then this is going to be cosine. And tangent is 5/12. What about sine? Second quadrant, you have negative and positive. So cosine should be negative. Sine is positive as given. It means tangent will be also negative. So we have all the value we need. So sine, double angle, double theta, 2 theta is going to be same as copying this formula. 2 sine theta times cosine theta. So it'll be 2 times sine theta times cosine theta. This gives you 1 negative. And when you multiply all this number, that makes it 10. So it'll be 120. 13 times 13 will be 169. So this value will be sine 2 theta. What about cosine 2 theta? That will be this formula. Or any of this formula will be okay, right? But if I wanted to use the first one, then I will have cosine squared theta minus sine squared theta. So it means square the value, right? Square the value gives you, you're squaring the negative, so it will be positive 144 over 169 minus 25/169. This gives you 119/169. What about tangent? You have a tangent 2 theta right here, right? So using that formula, you get 2 tangent theta over 1 minus tangent squared theta. Remember, our tangent value was negative 5/12. So it'll be 2 times negative 5/12, 1 minus negative 5 over 12 square. So this gives you reduced multiplications, right? So it will be negative 5 over 6 on the numerator. Denominator, you're squaring the negative, so it will be positive. So it will be 1 minus 25 over 144. This one become 144 over 144. So 144 minus 25. You get, I'm going to just leave the numerator as it is. You get 119 over 144. So if we simplify the complex fractions, this is dividing by 119 over 144. Division, we can change to multiplication and flip the second fractions. So it will be changed to multiplication, flip the second fractions. And when you reduce and multiply, you get negative 120 over 119. So once we know how to play with the formula, let's see if we can find the exact value. So we have cosine 112.5 degree. How do we get 112.5 degree? Well, if we divide, because we're looking at double angles or half angle, right? And I noticed that if we do cosine 225 divided by 2, you will end up getting 112.5. And we know that 225 degree is equals to, well, if it's a cosine 45 degree on the third quadrant. So using the half angle formula, this is going to give you square roots of, but then we need to get sign here, right? Which sign is that? The sign right there is going to be negative. Why? Because this angle right here is in the second quadrant, and second quadrant cosine is negative, right? So that will be negative right there. And then we have 1 plus cosine 225 over 2. And when we find the cosine 225, that's going to be square root of 2 over 2 in a third quadrant, which is negative. We can replace that into cosine 225, so it will be minus square root of 2 over 2 over 2. When we do simplifying the numerator inside of the radical, you get this one become 2 over 2 to add it. So that gives you 2 minus square root of 2 over 2 over 2 inside of the radical. And when we wanted to get rid of this large denominator, we could do multiply both sides by 1/2. So you get negative square root of 2 minus square root of 2 over 4. And this square root of 4 can be reduced. So the square root just on the numerator over 2 is what you can get for cosine 112.5 degree. So let's look at B also. 22.5. 22.5, we know that's going to be same as 45 degree divided by 2, right? So we could say this is sine 45 degree over 2. And this is going to be first quadrant. 22.5 is first quadrant. So your sign is going to be positive. And you have 1 minus cosine 45 degree over 2. If we wanted to go back to the formula with the half angle, don't forget that's the half angle formula, right? So when we replace that value, we don't need to copy down positive signs. It will be just square root of 1 minus cosine 45 degree is square root of 2 over 2 over 2. When you simplify the numerator, this is going to be 2 minus square root of 2 over 2 over 2. So when you rationalize it, not rationalizing, but get rid of the complex fractions, this is going to be square root of 2 minus square root of 2 over 4. And this time, let's look at 75. 75 degree, if we wanted to use the half angle, that's 150 degree over 2. What else do we know about? 150 degree is same as cosine 30 degree on the second quadrant this time. And cosine 30 degree is square root of 3 over 2. Cosine in a second quadrant is negative. X is negative in a second quadrant. So that's the value you're going to use. And tangent half angle formula, you need to know sine also. So let's figure out sine 150 degree is equivalent to sine 30 degree on second quadrant. Sine 30 degree is 1/2. And second quadrant or y value, which is sine, is going to be positive. So with that two value, let's plug into the formula. The formula of tangent half angle, I'm going to use 1 minus cosine 150 degree over sine 150 degree. So then I can replace cosine 150 as negative square root of 3 over 2. Sine 150 degree was 1/2, right? This is same as adding. So 1 plus square root of 3 over 2 on the numerator, which is going to give you this being 2 over 2. Let's change that. Let's change that to 2 over 2. So we will have same denominator. And that gives you adding. So it'll be 2 plus square root of 3 over 2 all over 1/2. When you get rid of complex fraction by multiplying by 2 on the numerator and denominator, you will get 2 plus square root of 3 remains. And that's going to be tangent 75 degree value. Let's try example 3. Use a half angle formula to find exact value again. So same types of problem as the problem we're looking at it from the example 2. So this 15, we know cosine 30. So we do 30 divided by 2. This gives you, plug into the formula, which is 1. And cosine 15 is first quadrant. So that's why I didn't put any sign, but that will be positive, right? And plus cosine 30 degree over 2. And what's the cosine 30 degree? Cosine 30 degree is going to be square root of 3 over 2. So when you change this 1 into 2 over 2, you get 2 plus square root of 3 over 2 over 2. Multiply by 1/2, right? To get rid of complex fractions, you get 2 plus square root of 3 over 4 inside of positive square roots. And this can come outside of the square roots is the value of cosine 15 degree. What about if you have a negative angle this time? Well, then you need to use even odd function first. So sine is odd functions. So you can bring the negative outside and just talk about the 15 degree. So then this is going to be negative sine 30 degree over 2. And this is going to be negative 15 degree. Negative 15 degree, that's in the fourth quadrant, right? Negative 15 is fourth quadrant, so your sign must be negative. And then square root of 1 minus cosine 30 degree. That's square root of 3 over 2 again, over 2. And when you simplify the numerator, that gives you 2 minus square root of 3 over 2 over 2. Let's multiply by 1/2 both sides. To get rid of complex fractions, you get 2 minus square root of 3 over 4. That gives you negative square root of 2 minus square root of 3 all over 2 as the solution for sine negative 15 degree. Example 4, if we have cosine theta equals to negative 3 over 5, and look like this is third quadrant. We wanted to find exact value of all this half angle. So because we're looking for half angle, we wanted to make sure which quadrant the half angle is going to be. So we're going to use this theta in the third quadrant, dividing by all three sides by 2 to make half angle in the middle to see which quadrant this is going to be in. That's going to be 90 degree, half angle, and that's going to be 135 degree. This means this is going to be in second quadrant. Second quadrant, you have negative and positive. So using that, your sign is going to be positive, and plug into the formula. So this is positive, but we're not writing it, right? And cosine theta over 2 is the formula. So when you replace that cosine theta, you get 1 minus negative 3 over 5 over 2. Because 1 becomes 5 over 5, you get 5 plus 3, so it will be 8 over 5 over 2. And when you multiply by 1/2 to get rid of complex fractions, you get square root of, let's reduce, you get 4 over 5. And square root of 4 is 2, and you have square root of 5. When you rationalize that, you get 2 square root of 5 over 5 for sine theta over 2. So now B, cosine theta over 2, cosine is the x value, so that will be the negative. And when you plug into the formula, you get 1 plus cosine theta, and your cosine theta is given, which is negative 3 over 5 over 2. And again, 1 being 5 over 5, you do 5 minus 3, you get 2 over 5 over 2 inside of the radical. And you multiply both numerator and denominator by 1/2 to get rid of complex fractions. You get negative square root of 1 over 5. When you rationalize that, you get square root of 5 over 5 with this negative, right? What about tangent? Tangent, if cosine is negative, sine is positive, tangent must be negative also. So tangent is negative. And the formula on this one is 1 minus cosine. So it will be 1 minus cosine over 1 plus cosine. And if 1 being 5 over 5, you get 5 plus 3 is 8. And 5 minus 3 is 2. And when you multiply numerator, denominator by 5, you get negative square root of 8 over 2, which is square root of 4. That's negative 2. And this is how you're going to find exact value with the full angle given and when you're looking for a half angle. So we did how to solve or find exact value by using half angle and double angle before. And now using those formulas to see if we can verify it, right? So look like if I pick this side, even though this side looks longer, if I pick the left side, I can use the addition formula, right? So this, I can rewrite it as cosine of 2 theta plus theta. This will give you cosine 2 theta times cosine theta minus sine 2 theta times sine theta. And cosine 2 theta is double angle. So again, we're going to replace that with the formula, which is 2 cosine squared theta minus 1. And then you have a cosine theta, right? That was the double angle. Just change it. Followed by the formula, right? And then this is another double angle. So sine 2 theta is 2 times sine theta times cosine theta. And sine theta was there before. And then let's see if we can distribute, open the parenthesis, right? So then you get 2 cosine cube theta minus cosine theta minus distribute, right? This is distributing. Wait, this is multiplication, so you cannot distribute twice. So just one time multiplying. You will get 2 sine squared theta and cosine theta. Then what do we do? Let's see. Oh, this one right here. Remember, whenever you see square, you wanted to see if you can use the Pythagorean identity. So let's see if I can rewrite this with Pythagorean identity. 2 times 1 minus cosine squared theta, cosine theta. And let's distribute that, which means open this parenthesis. That will give you minus 2. So look like you're not just distributing cosine theta here and there. You also need to distribute 2 also. So it'll be 2 cosine theta, and this negative makes it positive, 2 cosine cube theta. So now you have a like term. This 2 is the like term. When you add it, you get 4 cosine cube theta. This 2 is the like term. Give you negative 3 cosine theta. And that's what you have on the other side. So this proves that you can get, you can make left side equals to the right side using those formula we've been learning from last 2 sections. So this time B, I'm going to work on the right side this time because I see double angle there. So then I will have 1 minus that double angle. I can rewrite it as 1 minus 2 sine squared theta over, that's another double angle, sine 2 theta is equals to 2 sine theta times cosine theta. You wanted to make it larger so you know more stuff to do. Let's open the parenthesis by distributing negative on the numerator. Give you plus 2 sine squared theta over denominator. And this 1 minus 1, they cancel out, right? So you only have 2 sine squared theta over 2 sine theta times cosine theta. 2 over 2 cancel out. This 1 sine theta will get rid of one of the sine theta on the numerator. So then you only have sine theta over cosine theta remaining. And we know that's tangent theta, right? Which is the other side. Problem C. This one, it don't matter which side you're going to start it. You can start with the half angle because we know how to change half angle into the formula, right? Or this time, this side on the right side, it's not related to sine and cosine, so I know I can do something with that side also, which means, I know I can change cosecant into 1 over sine x and cotangent into cosine x over sine x. And then go from there, right? Because same denominator, let's do the subtractions. That will be 1 minus cosine x over sine x. And we know that's the half angle formula. So half angle formula for tangent. And that's what we can do. If we started from here, you will go that way, right? Because half angle, tangent half angle formula will be this. And when you separate it into 2 terms, because you have a 2 term on the other side, this is what you're going to get, right? So either side, you can start working on it if you have something that you know what you need to do. So that's how we're going to verify it, using more of the formula that we are learning.